Welcome, everyone, and thank you for joining us for another Lunchtime lecture. Our speaker today is Adam Rabinowitz, and his lecture is the Planet Texas 2050 Grand Challenge, Building Texas Resilience Through Transdisciplinary Research at UT. Professor Rabinowitz is Associate Professor in the Department of Classics and Acting Director of the Institute of Classical Archaeology at UT Austin. He holds a PhD in the Interdepartmental Program in Classical Art and Archaeology at the University of Michigan and is a former fellow of the American Academy in Rome. He specializes in the archaeology of Greek colonization, culture contact, and ancient food and drink. He is currently developing a multidisciplinary research project in partnership with the Romanian Institute of Archaeology at the site in Istria in Romania. It is unfolding in conjunction with the broader Planet Texas 2050 Grand Challenge Research Initiative at UT, for which he is a founding member and the 2021-2022 chair of the Theme Organizing Committee. With colleagues in geography and geosciences and integrated biology, he is the co-PI of the Planet Texas 2050 Stories of Ancient Resilience Flagship Project. You're going to hear about incredible and ambitious work happening right now on the 40 acres, so help me welcome Professor Adam Rabinowitz.
Thank you very much, Patricia, for that introduction, and thank you to the X's for inviting me. One of the things that I love about working at UT is the passion and engagement of its alumni community. So you guys are great, and maybe there are some of you out there who I've had in a class, in which case it's nice to be in a virtual room with you again. Oops. I am here today to talk to you about the Planet Texas 2050 Grand Challenge. It's one of 3 Grand Challenge projects that have emerged from the university through the Office of the Vice President for Research over the last 3 or 4 years. And I wanted to talk to you about both what we're doing and how we got to this point so that you can see both the kinds of innovative research that are happening at UT and the way that a project like this, with very ambitious goals and a fairly short timeline, can develop. So I'll start with an explanation of what this project is and how it came to be in the first place. And then I'll move on to describe some of the research that we've been doing and the changes that the Grand Challenge has gone through to get us to where we are today. So the Planet Texas 2050 Grand Challenge came out of an initiative of former President Greg Fenves and the Vice President for Research, Dan Jaffe. When Dan Jaffe took office in 2016, he decided that the university needed a moonshot research program, something that would pull together researchers from all sorts of different areas to work together on major problems that confront society and even humanity, and come up with plans for potential solutions to some of those problems, or at least interventions in those problems, that could be done in a specific period of time and that would use both the unique resources and expertise of the UT Austin community and have an effect on the population of Texas and ideally, eventually, the broader nation and the world. So the project was called the Bridging Barriers Initiative, and it was meant to bridge barriers between disciplines and also barriers between academic research, which sometimes seems detached from reality, and real world problems that we're all confronting. There was an open call that went out to the university community as a whole, indicating that the Office of the Vice President for Research was open under this program to proposals for interdisciplinary research questions and projects. Any faculty member could submit as long as there was an interdisciplinary team. They originally expected, I think, maybe 40 or 50 applicants or applications, but instead they received 125 project applications or project proposals from clusters of faculty representing more than 800 members of the UT research community. So this was a pretty substantial return on that initial call. And having received these 125 different proposals, the Vice President for Research and his office began to sort them into rough groups, thematic groups that seemed to tie together a pretty disparate bunch of project proposals. So those thematic groups were, there were 8 of them to begin with, and they went forward with small committees composed of individuals who had been the corresponding authors on those initial project proposals, the contact authors, who were then put in a room together and asked to figure out a collaborative research project that made sense, that fit into the idea of a grand challenge, a real confrontation of problems, major problems facing us, and real world solutions, and produce a project plan. Of those 8 thematic groupings, only 3 managed to make it to the project plan stage, and those have now all launched. One of them is Planet Texas 2050, which I'm talking to you about today. Another is Good Systems, which is focused on the future of artificial intelligence and society. And a third is Whole Communities, Whole Health, which is working on scientific approaches to help Texas and our broader society thrive, especially from the perspective of health and well-being. Now, what this meant was that groups of people who had never had any contact before and who had very different disciplinary backgrounds were thrown together. You might be asking why an archaeologist is on an organizing committee for a grand challenge project focused on the future. We usually deal with the past, this is true. But in this case, I had been the contact author on a proposal to connect archaeological evidence and historical evidence with evidence about the environment in the past to understand previous responses to climate change and climate stress. And that is why I was put in a thematic cluster focused on sustainability and asked to join a group of people who included a geoscientist, a civil engineer, an English professor, an urban planner, an economic geologist with a specialty in soil science. And originally, there was also an astronomy researcher who focused on exoplanet research. So I know this sounds like the punchline to a bad joke. An archaeologist, a geoscientist, a planetary astronomer, and an urban planner walk into a bar. And it felt a little awkward at the beginning, but it quickly became apparent that there were intersections in the work that all of us were doing, and that by working together, we could accomplish something much bigger than any of us had been involved in individually before. So this was the original theme organizing committee. Pretty quickly, we added a representative from the Texas Advanced Computing Center and a representative from the Dell Medical School who specialized in public health. And we began talking about how we might leverage our various research programs, interests, and areas of expertise to create a project that could affect the future of our state and our country, with an eye toward specifically sustainability and the presence of various challenges associated with climate, in the case of most of us. And we spent some time just trying to figure out what this project might be until Jay Banner, the geoscientist I mentioned above and the director of the Environmental Science Institute, pointed out that there is a traditional dry line that runs down the 100th meridian in Texas, separating arid West Texas from humid East Texas, and that the dry line has been migrating slowly eastward over the last couple of decades and is projected to migrate even further to the east as the temperature warms and as the effects of climate change become more pronounced. At the same time, the state demographer had predicted in the mid-2010s that the population of the state of Texas was likely to double from what it was in around 25, 26 million people at that time to more than 50 million people by the middle of the century. It is also rapidly urbanizing. More than 88% of Texas's population currently lives in the metro area of a large urban center. And on this map of Texas, those gray areas within that red box all represent urban agglomerations where most of the population is densely clustered together in urban environments. Now, if you look at that map and imagine the dashed line moving slowly eastward and the gray areas growing larger and larger, it's pretty clear that in a relatively short period of time, those two phenomena, our demographic increase, our urbanization, and the increasing temperatures and potential aridity and scarcity of water are going to intersect. And that's going to make things very difficult for us. And we've seen that some of the extremes of weather patterns in the last few years that are most likely the product of larger climate change phenomena have started to create pretty significant challenges for people in urban areas. Anybody who lived through the snowpocalypse or icepocalypse, however you want to talk about it, the freeze of February of this year, knows that a lot of those systems, water, electricity, were put under severe stress by this extreme weather. And we expect that there are going to be more events that stress those urban systems moving forward. And that gave us our starting point for our shared grand challenge. The idea that Texas is going to face twin challenges in its demographics and the pattern of where people live, and in the climate that it faces as it moves forward through the 21st century. And that one of the things we could do to help mitigate these problems is to focus on ways to make Texas resilient moving forward with a specific eye toward water and urbanization and urban populations and climate change. So this is the origin of the project and how it emerged. We took a series of principles as our starting points. We wanted to make sure that there was an even balance between the STEM disciplines and the arts and humanities, so that we weren't proposing only technological solutions or examining phenomena solely from the perspective of quantitative disciplines, but that we were actually looking at society and social responses and human behavior and human emotions and psychology in framing our agenda. We wanted to make sure that all of the pieces that we were using worked together and integrated with each other in various ways, not a complete overlap, but a communication between the various bubbles that you see here. We had a lot of diagrams in the early years of the project where we tried to sketch out what was happening and who was talking to who else. One of the things that we thought would be fundamental to this communication between disciplinary areas was the focus on data and data management that TAC could help us with, and not only the aggregation of different kinds of quantitative and qualitative data, but also the development of platforms and interactive visualizations that could help communicate what those data meant to broader public audiences. And that was another one of our founding principles, that we wanted to work not only for the public, but with community partners, stakeholders at the level of nonprofits, at the level of state and federal agencies, at the level of industry, at the level of individual communities deeply affected by climate or demographic change. So one of our goals from the beginning was to involve community partners and stakeholders in the co-development of our research plans. At this point, I would say we were definitely coming into it multidisciplinary, because we had a number of people from different disciplines sitting at the same table. That's the sort of lowest level you can get when you start to break down disciplinary barriers. You simply are all in the same room together and you are trying to learn a shared language. Once you've learned that shared language, however, you can start creating interdisciplinary projects. And this is what we did in the first stage of Planet Texas. We tried to find ways that we could not only work in parallel, but that we could integrate our work in one discipline with the work of our partners in other disciplines. And I have to say that none of this would have happened without the support of the Bridging Barriers program and the Office of the Vice President for Research, and specifically with the provision of a program director for each of these Grand Challenge projects, who helped us to focus our discussions, think through what we were doing, create plans, and move forward, to move from ideas to concrete actions. And we were very, very lucky at the beginning of the program to have Tessa Green, who is now the broader director of Bridging Barriers work, help us understand how we could approach the problems that we had identified. We then had Jenny Nelson Gray, who came to us with a background in NGO and international development work, specifically in food and agriculture. And she brought another unique perspective from the nonprofit world that helped us shape the projects that we were envisioning. When Jenny left, Dave Kramer came to us again with an international development background, but this time one more focused on education and outreach. And that again helped us to think about how we would engage our community partners and who we were working for. And we are now working, we're lucky enough to work with Heidi Schmalbach, who comes to us from an arts background in New Orleans and has helped us to focus on some of the artistic outreach that we're going to talk about shortly. So the program directors have been integral parts of the team as we move from ideation in those early stages to actual concrete action. In the first phase of the Planet Texas project, so we figured out what our problem was, we figured out how we wanted to address it in a broad sense, what areas we wanted to concentrate on: water, urbanism, climate, temperature. But we had to then turn that into action, and we had quite a short time to do so. So when we started the project, which launched formal activities in January of 2018, but was sort of announced in the fall of 2017, we focused on what you could think of as shovel-ready projects that the various members of the organizing committee and the close collaborators who had stuck with us during that somewhat chaotic ideation process already had going or could build on research that people had already begun to develop. And so some of those projects you'll see here, I just wanted to mention a couple of them. One of them is the Texas Metro Observatory. This was a project to gather data about phenomena related to urban challenges, urban growth, temperature, other factors, air pollution, and put it together using, again, the resources of the Texas Advanced Computing Center in spatial visualizations that could help understand where particular kinds of challenges were located and how they unfolded on a spatial level. And that was led by Fernanda Leche and Catherine Lieberknecht, an engineer and an architect or an urban planner, both of whom are past chairs of the theme organizing committee, and whose project then led to one of the more developed flagship projects we'll talk about in a second. Another of these is the project that I was most involved with, and I throw this in because I can't help it, but I also wanted to provide an illustration of why the past might be relevant to the challenges we face in the future. A lot of things are different. We have different levels of technology, we have different energy sources, we have larger populations, denser urban settings. But in many cases, human responses to stress, social stress, environmental stress, are pretty similar over time. And so this project wrapped up research in Mesoamerica, focused on the Maya world, which experienced a climate-related crisis at the end of its period of development, and on the Roman Empire and the city of Rome itself, one of the largest cities of the ancient world, maybe 1 million people in the 1st century AD, and an empire that also had difficulties as climate conditions and environmental conditions changed over time, leading to systems that had been established starting to work less and less well. And we also wanted to look at Texas. Texas doesn't have a very long urban history, but it does have urban settings that arrived with Spanish colonization. And so we were also looking at the acequia system in San Antonio and its evolution over time as the early modern period came into the modern period. And we were trying to understand water management in these areas, many of which are prone to drought or vulnerable to it, and also human and animal mobility in those areas. So the map that is playing on the bottom right of the screen is zooming in from the landscape level at the site I work at in Romania, where we were looking at the isotopic values of water sources and geology, which can be read from human teeth to understand human mobility, and then zooming all the way into a major urban settlement of Greek and Roman antiquity, and down to the level of individual Roman burials, which we are now analyzing both for isotopic profiles that might tell us how they are moving around the landscape and whether they were local or non-local, but also genetic data that can help us understand the relationship of the people in this cemetery to each other and to the broader population at the edge of the Roman Empire at a time of major population movements and migration. In the second year of the project, so the first year we grabbed these things that people were already working on or could spin up very quickly and started putting those together and seeing where they intersected and building infrastructure on the data side. In the second year, we issued an open call to the university as a whole, asking for collaborators and for people who might want to come and speak with us or work with us, and soliciting project proposals from UT in general. And we got a very large number of excellent proposals. We were able to fund about 15 of them, I think. And here's an example of one of those proposals. It didn't come to us from the beginning, but it intersected with these questions of both water and climate that are driving the grand challenge as a whole. It's looking at the vector for a very unpleasant bacterial disease called melioidosis, which is a tropical disease, but the temperature change is bringing it up into Texas, making Texas a more suitable environment. And the persistence of flooding and the increase in the amount of flooding, which carries this bacteria onto people's skin, is also increasing. So this is another way to look at these climate-related risks that we are facing as we move forward into the middle of the century. Another proposal took a different tack entirely. Rather than looking at something focused on science and research, this was an escape room project that took the challenges Texas is facing as a starting point. It put the participants in the escape room game on a research station on a platform in the Gulf as a hurricane approached. And the participants in the game were asked to solve the escape room by transferring data from this platform to a base on the shore to advise on how the people on the Texas Gulf Coast might respond to the hurricane, who needed to be evacuated, and then doing this all in time to get yourself evacuated from this platform. It was a very exciting thing that made the experience of climate change and extreme weather much more personal and direct and visceral for the participants. So in the last 2 years, the program has evolved substantially by taking those initial projects and that second round of projects proposed by the community, condensing them and combining them into a series of 6 flagship projects that are more focused and more geared toward the resilience outcomes that we're looking for. So those flagship projects are now the basis of Planet Texas activity moving forward. We also started to initiate a process of change and rotation in the organizing committee and the participants to open opportunities for more people to be involved at a leadership level. So this is our current organizing committee, and you'll notice that I am the only one of these people from that original walk into a bar joke to be there. But the new participants have all brought different kinds of skills and different perspectives that enrich the project and make it more likely to succeed. And they also help us to keep breaking down those disciplinary silos that the project hoped to confront. So these are our 6 flagship projects, which will now be moving forward through the next half of the 2020s. And they bring together many of the former projects to focus the work on particular questions and issues related to resilience. And I'm going to discuss only a couple of these. You can get a sense of the range of them on the Planet Texas website, and you can see them here. But one of the things that you might see in this first slide, the first 3 programs, is an increasing emphasis on that stakeholder engagement and community participation that I was talking about. So what we're hoping to do is really cultivate communities, the city of Austin, communities within the city of Austin, different parts of the state of Texas, to act as partners in the research that these flagships are moving forward. The 3 that I'll talk about are these last 3, because some of the results that we can see are already starting to emerge. And the first of those is called Networks for Hazard Preparedness and Response, and it draws on some of those mapping and data management activities that I mentioned before. to create better maps of where urban areas in Texas are going to flood under certain rain conditions, and make those available as interactive tools for first responders who can figure out on the basis of these maps and their own locations whether their area is likely to flood and whether people need to be evacuated or not. This is the Pin to Flood tool, which is already starting to be used by first responders and disaster managers in Texas. And as that project develops, it'll look on a broader level across the state and start to be implemented in other places outside of Texas as well. These problems of flooding are not specific to us. They're going to affect a lot of coastal communities moving forward. Another of those flagships is the flagship led by the Texas Advanced Computing Center, Integrated Models for Complex Decision Making with AI. And this is a project to use high performance computing tools, modeling, and data management platforms to start pulling together all kinds of different data that are being generated by these various projects, put them together where appropriate in predictive models that can then be used to inform larger scale responses. And so you saw that a little bit with the flood mapping project, but there is a broader initiative called the Texas Disaster Information System that TAC is a part of that will be moving forward to make disaster planning information available for a broader range of responders who need to be involved. So not just for flooding, but also for fires and heat emergencies and other kinds of climate-related crises. That project also is working with qualitative data to try to understand how qualitative data can be combined with quantitative data to give us new information about the problems we're facing. And I highlight here the Sites and Stories project, which is a collaboration with the Museum of South Texas, which is taking historical photographs of floods from the past, geolocating them, and then using them as ways to understand how flooding might develop in the future so that people who are managing flood situations as they emerge can look back to historical data as well as contemporary data to manage those situations. That project is focused heavily, both of those projects are focused heavily on mapping and landscapes. One of the tools for that is LiDAR, which is a sort of a laser-based radar that allows you to get very detailed topographical maps of the ground. And this is a technology that the Stories of Ancient Resilience project that I'm involved with is also using to try to understand past settlement history and water management. And here are two examples of recent publications coming out of Planet Texas related work for the Maya region, where LiDAR initiatives have been able to rediscover a number of sites and monuments that are invisible beneath the jungle canopy, and also patterns of water use that might help us to understand how the Maya used water, how they adapted as their climate changed and became drier and they faced drought, and how we might do the same in Texas and in Mesoamerica. I also want to point out that a number of the projects are seeking artistic collaborations to try to find different ways to think about the data they're producing. And here again, LiDAR comes into play. This is a collaboration that the Stories of Ancient Resilience project has had with local artist Riel Sturkio, who has been working on a project called Skin Prints, involving very high resolution prints of small transfers of the sort of fingerprint of people's skin in connection with trauma and healing and bodily integrity. And the number of the Planet Texas Organizing Committee and members of SOAR did a collaboration where we submitted these prints with an eye toward resilience. And we're in ongoing discussions about how we might do something interesting with that technique and with LiDAR imagery, which you see on the right, which is sort of the same very close look at skin, except it's on a different level. It's the skin of the earth itself, which is also a palimpsest of change and history and trauma and recovery. And that leads me to the last piece of our puzzle right now, which is collaboration with the arts more broadly. And we have come to the conclusion that the integration of arts and humanities for research purposes is very productive. The creation of tools that we can use to respond to extreme weather and climate disasters in Texas is also really important for our resilience as a state. But the tools that we produce, the technologies that are involved, the data sets that we make public really mean nothing without the ability to communicate to the public their relevance and convince people to use them and buy into an approach that uses them. So the process of resilience is a process that is both scientific and policy focused and human and psychological. And we feel that the involvement of the arts is really important for that second part. So we established an artist in residence program, bringing together researchers and artists. We had an initial artist in residence, Marie Lorenz, who was working on the water courses, urban water courses in the area of Austin. And then we expanded that to a call for proposals for the current project year, held up a little bit by the difficulties of the pandemic. But we received a number of proposals and selected 3 artists in residence who are working on themes related to the larger problems and questions that the Planet Texas 2050 research community is working on. One of those is Lisiana Cruz, who is working with documentary formats to understand mobility and climate along the Gulf Coast, the displacement, for example, that followed Hurricane Katrina in New Orleans. Another is Monica Teresa Ortiz, who is working on writing workshops with community members to process stories of adaptation to climate change and responses, resilient responses to trauma and difficulty. And the last is UT's own drag production house at the Moody School of Communication, which specializes in very gripping podcasts. And they're working with us on a series of podcasts that relate to climate change and adaptation in Texas. And the one that has been, that is the furthest along, which I've listened to parts of and which is fantastic, has started with the Bastrop Fire of 2011, which many of us may remember. We're broadening and deepening our engagement with stakeholders. Here are just a couple of examples of the groups that we are trying to engage with. These are some of the most developed, but we have other groups that we are also reaching out to. And I'm not going to dwell on this, but I'm happy to answer questions because I see the clock ticking. And we are also integrating the research activities and the outreach activities that we're doing into our teaching on the UT campus. So students who are where you once were are having opportunities to work with Planet Texas researchers and take courses that address some of the problems and challenges and solutions that our project is developing. We've taught several graduate seminars, bringing in students across the university and breaking down those disciplinary boundaries even further. And project-focused courses in the School of Architecture and the School of Engineering that sought to engage students in the creation of solutions and sustainable practices and interventions. So this is where we are now and where we are moving. We're trying to increase our research networks with other institutions. We are carrying out collaborative research with communities and stakeholders into resilience. We're training students in working outside of disciplinary boundaries. And we're trying to develop innovative tools to manage climate adaptation, to visualize extreme events, help stakeholders plan and prepare. And the part that the past helps us with, we are trying to develop new stories and narrative frames to talk about resilience outside of the binary between either total collapse and failure and the post-apocalyptic climate literature that we see, and total success where nothing changes and everything is the same as it is and we can do exactly what we've been doing with no consequences, which doesn't seem to be an option on the table. And all of this is informed by approaches that center equity and equitable relationships with communities, equitable responses to climate change and demographic pressures in the work that we're doing. So I will leave you with this. We would love to have people reach out to us and contact us about what we're doing. There are a couple of opportunities that if you have students who are at UT or in Texas more broadly, some of the Texas X's, I imagine, have their own college-age children. We have a City Fellows program that the Equitable and Regenerative Cities Flagship has developed, which is open to UT faculty, research scientists, and postdoctoral fellows to work with the city of Austin to create resilience nodes. And then we have a research experience for undergraduates funded by the NSF housed in the Environmental Science Institute with a number of Planet Texas mentors working on challenges to the sustainability of urban systems from an interdisciplinary perspective. And I've provided some contact information at the bottom, and I think that I have left less time than I wanted for questions and discussion, but I will leave it at that. Thank you very much for your attention.
Thank you, Dr. Rabinowitz. I'm just jumping into a couple of questions, and the first one is really about, what are some of the difficulties and opportunities when you integrate STEM and arts and humanities? Can you talk a little bit more about that? You hit on it, but what are some of the difficulties? We'll start with that.
Yeah, and that was certainly a place where I found myself. I mean, I'm already a liminal person in disciplinary terms. Archaeology is somewhere between humanities and social sciences. I've been in several meetings where I was sitting there and somebody would say, well, we don't have any humanists involved right now. And I would say, but I'm a humanist. But the biggest challenge, I think, was learning to speak the same language. We think differently about problems, but we also have very different disciplinary languages, from the basic level of acronyms that you understand to funding sources to the way that we model the work that we do and the outcomes that we expect. Humanities researchers are used to having outcomes that consist of ideas. Engineers are used to having outcomes that consist of tools and solutions, and trying to find common ground between those different perspectives was probably the most challenging thing. But it was also the most fruitful thing. The opportunities that emerged when we found that common language were incredible. So I'll give you a personal example. I work with human populations in the Greek and Roman world, and I'm very interested in questions of what people were eating and where they came from and where they were buried and whether those are different places. And I learned in the first round of meetings, having been introduced to Jay Banner, that UT has isotopic analysis labs on campus that can do some of that work. And I had been working at UT for 15 years at that point. And I'd even done isotope work with partners in Germany because I didn't think that there was anybody on campus who did it. And so learning that, we've now established a partnership with 2 of the isotope labs in the Jackson School. And I have 3 classics graduate students right now who are receiving training in isotopic analysis so that they can work on human populations in their own research from a different perspective that brings together both the historical and the scientific. So that was a revelation for me, and I can see that happening with many of our other projects as well, these unexpected connections that emerge and that show us where the data that we're collecting, which we thought was relevant only to our particular communities, can actually be repurposed and reused by other groups who want it for different things, and will discover different information and knowledge from it.
Well, that's wonderful. I mean, did you have a situation where you had some barriers that were significant and you just sat down and specifically worked them out? And what were some examples of those barriers, if you can recall one?
Yeah, so I think actually the biggest barrier that, and everybody's perspective is going to be different about this, but I will say that the thing I had the hardest time with, and that several of the other more sort of science-focused groups had the hardest time with, was the community-engaged research, the participatory research that brings in people outside the academic community as equal stakeholders and co-developers of research questions. This is not something that archaeology often does, although there is a movement in archaeology to make that more common. And it's not something that some of the other disciplines that were represented at the table usually do. Sometimes we do things that we think will benefit the public, and then we show those things to the public at the end of our projects. But it's pretty rare to sit down from the beginning with partners, develop a relationship of trust, and then work with those partners to try to solve problems that are relevant and important to those partners, rather than do the stuff that we wanted to do and wanted to know about, and then assume that other people also want to know about that and then tell them about it. Yeah. And so that has been, it was a pretty significant barrier, just identifying stakeholders. And one of the things I think that Planet Texas 2050 has done very well is to integrate not just the principle of community engagement, but an actual program of community engagement with a community engagement specialist, a series of resilience roundtables, which we plan to resume, that brought together community partners and researchers, and a framework for developing those kinds of partnerships that even those of us who were unfamiliar with that method of working could use to change the way we do things in, I think, very healthy ways.
We've got a huge coalition of different kinds of disciplines and people involved in this. So one of our questions is, how did UT fund all of these projects? What was the structure there?
Right, and this would not have happened without a significant financial investment from the university. The Office of the Vice President for Research has essentially allotted, I don't know, I can't speak for the other projects, but our initial, the initial discussions basically indicated that there would be about $1 million a year to fund the activities of the flagships. And we were expected to raise external funds, and all of us have been working very hard to do so, which there's another barrier that is hard to bridge. Somebody in the sciences, for instance, doing cancer research, can turn to the NIH and get a multi-million-dollar, multi-year grant. The biggest grant you generally get for archaeology is maybe $250,000 for 3 years. And that's if you're doing scientific archaeology. And if you do humanistic stuff, then you're looking at maybe $50,000 once every 7 years from a funding agency. So we've all been working to raise the external matching funds, or ideally surpassing funds for that $1 million a year investment. But this was made possible because there was the funding to engage people in the research, to engage community partners, to fund graduate students, to fund lab development and expansion. So it is certainly something that wouldn't have happened without a financial commitment, a substantial financial commitment on the part of the university.
Perfect. And we have another question is, do you know if there are any projects that are involving business or government responses to climate change?
So our project has been reaching out to industry partners in particular. And we've had some funding. We had a postdoc who was funded by Dow Chemical. And we are also reaching out very aggressively to local and state government. We are working on ways that we can start working with policymakers at the governmental level to coordinate responses to climate change. And we are still very open to industry partnerships where our interests align. And there's another partnership actually that is being funded by Microsoft, which relates to some of the high performance computing activities that are going on. So this is something that was also built into our activities at the beginning. And we are constantly looking to expand our partnerships in the business and governmental communities, as well as nonprofits and community groups.
In a perfect world, how would Planet Texas 2050 inform policy in Texas? In a perfect world.
So in a perfect world, I think that we would have produced a series of tools that policymakers could use on a practical level to deal with climate crises or weather crises. So if you have a flood or a fire, we've provided the sort of foundation for a response without everybody having to invent that wheel themselves. And on the narrative level, to be honest, I think that one of the things that we are trying to accomplish is allow us to discuss policy in an informed way using trustworthy factual information that we actually trust as a society, and to recognize that some of the choices that we're going to have to make are hard and that people are going to lose things. And in making those choices, paying close attention to not focusing the loss on groups that have already had to sacrifice, and on finding ways to grieve and process those losses and move forward. That's the dichotomy that I was talking about in a narrative sense between success or failure, collapse or flourishing. It's not that simple. There is another category there, and that has to do with transformation. And transformation means some things stop happening and get left behind, and other things move forward. And the things that we see as our collective core values, if we can have an easier and more productive discussion about that, and that then those core values can inform our policy as we go forward with an eye toward equity, so that again, the damage is not concentrated on the most powerless to stop the damage, then I think we'll have done what we set out to do.
Okay. I think we have two more questions. One of them is, do any of the research projects involve researchers from other universities? So people like maybe in Minnesota or Louisiana or California?
Yes, we have a pretty broad range of collaborations. Many individual projects have researchers from other universities because of the shared interests. So I collaborate with a researcher from Pennsylvania State University, from Penn State, who does the genetics of the ancient oral microbiome from dental calculus, which can tell you about what people were eating and where they came from, and we don't have that capacity on campus. So there are sort of ad hoc collaborations within the projects, but there are larger collaborations, especially in the integrated modeling flagship project, the Equitable and Regenerative Cities flagship. These are both working with, so UT El Paso is part of the integrated modeling project in collaboration with the University of the Rio Grande Valley, University of Texas Rio Grande Valley. We are working with universities in Louisiana on some of the flood modeling and urban response material, because they have some of the same challenges. We share a coast with them, and whether we get hit or they get hit is sometimes a matter of which way the wind happens to be blowing. And I think that there are some broader collaborations that extend to the University of Arizona, for example, and other southwestern universities. So we've got connections across the South and the Southwest. We are not currently doing anything with California that I can think of, although there are several Grand Challenge projects that are similar to ours. But we're also constantly looking for opportunities to make connections and work with other institutions. So that is also baked into the structure of the project, for sure.
And one component of that question was, and I missed it, was, are there collaborations between northern universities like in Minnesota or Wisconsin, things like that, that have very different weather-related entities and outcomes and events?
So far, not that I'm aware of. We've focused on a range of places that are confronting similar problems. That is flash flooding, sea level change, and shore flooding, and tidal surges, wildfires, and drought. And so that's the sort of range of places that we've been working with directly. I think it would be interesting to be able to apply some of the tools and approaches that we've been developing to places where the climate is quite different. And that's something that we'll keep an eye out for down the road. But the opportunities that have presented themselves have tended to be a little bit more regional.
And it sounds like that these collaborations are helpful more than a hindrance. Is that accurate?
Oh, yes, definitely. And they increase the possibility that the things we're doing will actually have impact.
Yeah.
So the integrated modeling group is also collaborating with Texas A&M on the Texas Disaster Information System, which A&M is a lead for. And that collaboration means that the stuff that we're building here is going to really inform responses to disasters across the state in a way that would be harder to achieve by ourselves.
So our last question is kind of taking it back to the top, and we're talking about the recent winter storms in Texas. What are your thoughts on the way Texas managed that, and the preparations and post-storm recovery efforts? We knew it was coming, it happened, we handled it this way afterwards. Do you have any words of wisdom that you can share on that?
Yeah, and that is a great question, and this is one of those areas in which I'm learning as I go along. I'm an archaeologist. I can talk to you about lots of past disasters, but present disasters catch me as much without electricity as many of you for several days. I think that it highlights the fragility of the interlocking urban systems that we rely on because we didn't just lose power, then we also had, in Austin at least, we had a boil water notice because the water processing plants went down. It's the second time since I've lived here that I couldn't drink the tap water in a major growing, forward-looking, technologically adept American city. And I think that what it highlighted was a crisis of long-term forward planning. So we can't necessarily predict when a really extreme weather event is going to happen with a lead time of more than a couple of weeks, or maybe even only a few days. So we did know it was coming, and people took individual preparations to the extent that they could, and bought food and things like that. But the bigger problem was that our energy infrastructure wasn't prepared for that kind of weather, because on an actuarial level, it didn't seem that likely. And I think we are realizing that we have to change both our conception of what likely means in Texas and our ability to predict the effects of catastrophic failures of one part of a very complex system. And this is, again, where the work that we're doing with predictive modeling is really important, because if we understand that this part of the system, if it collapses, will bring everything else down with it, and that we now have a much greater chance, statistically speaking, in terms of probability, or just in terms of likelihood in a vaguer way, of that kind of extreme event happening, then maybe that's an incentive to go and shore up that system, even if it's expensive. And I hope that that's a lesson we learned from the winter storm. It remains to be seen, right? Human beings, this is one of the problems that we face as a species. We are very good at short-term thinking and planning. We're okay at medium-term planning. We are very bad at risk assessment, right? The thing that happened to me last week I see as the most major risk. The thing that is likely to happen to me in 2 years I see as not a risk at all. And we are not really good at thinking at timescales beyond our own lifetimes. It's really hard to say, what do we need to do to make sure that Texas is resilient in 2075, in 2100? And what we're trying to do is help people think in those ways and maybe mitigate some of our natural species level deficits about risk assessment and reactive responses to problems rather than proactive responses to potential problems.
Well, thank you so much for joining us today and sharing more about the amazing work that Planet Texas 2050 is doing here at the university. I think I kind of speak for everyone when I say that I'm very excited to see how the team's research impact the state in the coming years and how we react to that. So thank you again for your time. We truly appreciate you joining us. And thanks to everybody that joined us today for our November event. We'll be sharing details about our upcoming lunchtime lectures with you very soon via email. So thank you all again for attending, and we'll have a wonderful week.
Thanks very much.